In today's exciting episode of Geometry, we discuss linear measure. So, what lengths are we willing to go to learn geometry? Measuring line segments. A line segment or a segment can be measured because it has two endpoints. A line goes on forever, it's infinite in opposite directions, where a line segment is a piece of a line. It has a beginning and it has an end. Those are called the endpoints. A segment with endpoints A and B can be named as, we would say, segment AB or segment BA. You'll notice the difference in the symbol that's over those endpoints. It doesn't have any arrowheads on it. So if it was line AB, it would have arrowheads over at the ends of each of those little segments. But since it does not, this designates that this is a segment. The measure of segment AB is written as just AB. That's how we know they're just looking for a measurement there, or they're just representing a measurement. It's time for some example problems. All right, so we want to find the length of segment AB using each ruler. Okay, so if we look at the first ruler we have here, you'll notice we don't have in this ruler, there's no markings here. There's no markings between 0 and 1, right? We don't see any of these markings that typically may be on our ruler, right? So because of that, we can only approximate as to what this value here is for B. We don't know exactly what that value is. Because we don't, we go to the measurement we do have. So the nearest measurement we have with this ruler is 4. So we would say that AB is approximately 4. A squiggly equal sign means approximately. Now, in this situation here, we can look and we can see that AB does have the little markings between 1 and 2 and 3 and 4, right? We've got the millimeters marked, okay? So because of that, we can definitely see that B is sitting over 0.7, right? So we can say with some certainty here that AB is equal to 3.7. Now we're going to find the length of segment CD using these type of rulers. Well, if we take a look at this ruler here is in inches, as is this one here. Okay. Now, one of the things we would look at on this ruler is the fact that on this ruler, each space from each one of these markings between 0 and 1 is 1/4 of an inch. Okay, you'll see that there. Now, because of that, we would say, well, this length from here to here, that's 1/4 of an inch. You can't really see that very well. There we go. There's 1/4 of an inch. This is 1/2 of an inch. This is 3/4 of an inch. So we would come back and we would look at this. We can see point D is directly over 1/4 of an inch past 1. So we can say with some certainty that CD is equal to 1¼ inches, right? Now, this second ruler is much more precise. If we take a look at this, first we have a measurement here. This measurement is equal to 1/16 of an inch. This next one here is equal to 1/8 of an inch. Let's go with white here. It's easier to see on there. So that'd be 1/8. So you can see how this is more precise, because if I had a measurement, let's say I'm looking right here at this measurement, well, I could count 1, 2, 3, 4, 5, 6, 7/8 of an inch, right? I might be over here at this mark. I might come over here to this mark, right? And that's at 1 3/16 of an inch. So we're a lot more precise in this measurement. It's a lot smaller. We're getting smaller as to where the designations are, okay? And again, this ruler or this segment is, right? We would just say this is 1 1/4 inch. That's another way of expressing inches, is with the two little tick marks there, right? The quotation mark, okay? Okay, so for any two real numbers, A and B, there is a real number, n, that is between A and B, such that A is less than n is less than B, okay? So if we think about this, I can find a number, if I go between 1.9 and 2, well, I can go to 1.95. And between 1.95 and 2, I can go to 1.955. Okay, and I can keep getting smaller and smaller and finding numbers that fit in between those smaller numbers. Okay, so using this concept now, we're going to talk to you a little bit about the relationship of points on a line. It's called the betweenness of points. And basically what this says is if I have 2 points and there's another point in between, all right, so if I have 2 points such as A and D in this picture, right? So I can look at this and say, well, both P and B are between, right? I look from here and I look to here, well, these two are between. Okay, now mathematically speaking, when it comes to measurements now, point M is between point P and Q if and only if P, Q, and N, they have to be collinear, they have to all be on the same line. And you'll see here is that this larger distance, right? So P and Q are the farthest apart. So the longer distance, and we would say is equal to, we would maybe call this the medium distance plus the small distance, right? That the two smaller values have to add up to the larger value. And to use a math example, let's say the length of PQ is 5. Well, the length of PM, we might say, is 3.5. And the length of MQ would have to be 1.5. All right? And then that would be true. We would know that to be true. Time for some more example problems. Okay, so the first thing we're going to do, they say find the length of EG, and they assume that this figure is not drawn to scale. Okay, so EG means this measure of segment EG. So we would be looking at this segment here, from here to here. Well, what we've already talked about is this. If this piece here runs from here to here, so if this one here is 2 3/4, and this segment here is also 2 3/4, well, then it would just make a lot of sense that we can take and add the length of EF, right, plus the length of FG together to get the length of EG. Well, the length of EF is 2 3/4, so we're going to write down 2 3/4. And the length of FG is also 2 3/4. That's equal to EG, the length of EG. Now, we would take and add these values. 2 plus 2 is 4. 3/4 plus 3/4 is 6/4. And that's equal to E. But that's not, excuse me, EG. I don't have my G here. There we go. So this is equal to EG. Now I'm showing all these steps, right? 6/4, that's equal to 1 1/2. So 1 1/2 plus 4 gives me 5 1/2 is equal to the length of EG. Okay? Now it's your turn. Go ahead and look at this problem and see if you can't figure out what the length of AB is. I'll wait. Okay, now that I'm back. So we're going to take a look at this. Remember, we know that this length here, if I can find where there it is, this length here plus this length here is equal to this length right here. So I'm going to write, and they say find AB. So I'm going to say, well, I know that AB plus BC equals AC. And I suggest you write this out like this because this way you've got everything on paper, you know how it's set up, and now you just substitute. I don't know what AB is, so I'm just going to bring that down, AB. The length of BC is 5.8. The length of AC is 13.2. Now, by the rules of algebra, I subtract 5.8 from each side. At this time, it would be a good time to take out your handy-dandy calculator and to subtract 13.2 minus 5.8. And you would get 7.4. So AB is equal to 7.4. Okay, find the value of A and XY. If Y is between X and Z, XY equals 3A, XZ equals 5A minus 4, and YZ equals 14. All right, so we've got a bunch of information on this drawing here that we want to use. So we've got XY equal to 3A, YZ equal to 14, and the big one is equal to 5A minus 4. Okay, so let's go back to our rules. The small plus the medium equals the large, right? So the small one here is 3A. That's the way it looks like on my drawing. I'm going to go with it. Plus 14 equals 5A minus 4. So a little algebra review here, right? I'm going to subtract 3a from each side of my equation, and I'm going to end up with 14 is equal to 2a minus 4. Okay. So now I'm going to add 4 to each side, and I end up with 18 is equal to 2a. I'm going to divide each side by 2. 9 is equal to a, right? So I found a. Now I need to find xy. Well, 3 times a equals xy. So now I just take a out. I put 9 in. 3 times 9 equals xy. Oops, not that. That's not what I want to do. Xy. And 3 times 9, that's 27, is equal to xy. Oops, and I don't want that type of x either. xy. Now, you might say to yourself, now wait a minute, how can that be correct? Well, if we take a look at this, we can check our work. So let's do a little check here. And I always suggest that it's never a bad idea to check your work. So let's do a check here. Okay. So I know that 3 times 9 plus 14, well, that should equal 5 times 9 minus 4, right? Well, 3. So that's 27 plus 14. Is that equal to 45 minus 4? Well, 27 plus 14 is 41. And 45 minus 4 is 41. They came out, they're equal. We did it right. Okay, we did a little check here at the end. If you're unsure about your answer, it never hurts to plug in and check it. Okay, the next concept we're going to talk about are congruent segments. So segments that have the same measurement are called congruent segments. The symbol for is congruent to is an equal sign with this little squiggle over the top. So the way we would read the example there, we would say segment AB is congruent to segment CD. In math, we don't like to write everything out. We use symbols because, well, we're probably lazy when it comes to that, to be honest. We'd rather do math than write a bunch of stuff. If we wanted to write a bunch of stuff, we'd be authors or journalists. So, knowing this concept now, okay? So we've got various things called constructions. So a construction, there's 3 types of constructions. We have what's called a drawing, and that's just where we have to use measuring tools such as a ruler and a protractor. We measure, okay? Architects do drawings. Constructions are methods of creating these figures without the benefit of measurement tools. The ancient Greeks didn't have rulers, but they did have ways of measuring angles and measuring length, but they didn't use those in doing these constructions, okay? A sketch is just drawing it out as best we can freehand, and we just are trying to get a concept on paper so we can visualize what we're doing. So that's it for now. This was Linear Measure. We'll see you again.